Dear students, we now look at very important shortcut for proving divergence. Okay, there is a theorem saying that this theorem is actually necessary condition for convergence. If sigma un is convergent, then limit n tends to infinity un must be equal to 0. And if we go for the contrapositive of this one, which is equivalent of this statement, in other words, okay, if limit n tends to infinity un not equal to 0, from this we can declare this as per logic. This statement, okay, this statement and this statement are going to be one and the same logically, as per logic. Okay, if you do not have that idea, you please leave it and just remember this particular conclusion. If limit un is not equal to 0, then sigma un is divergent. I am taking the contrapositive. So without going for this detail, you just remember this one. If limit un is not equal to 0, then sigma un is divergent. We'll have a quick look at some problem. Question: test the convergence of the series sigma n equal to 1 to infinity n by n plus 1. Solution: given series is sigma n equal to 1 to infinity n by n plus 1. I call this as sigma un. Implies un is nothing but equal to n by n plus 1. I simply calculate the limit of this un. I'm not applying ratio test, I'm not applying root test, I'm not applying RABs, nothing. I am not applying any test. I'm just checking the necessary condition. If it is convergent, really it has to satisfy the necessary condition for convergence. Simply I am calculating limit un. Limit n tends to infinity n by n plus 1. Now I divide numerator and denominator with n, so that I get 1 by 1 plus 1 by n. When I separate the limit, I get it as equal to 1, which is not equal to 0. Since limit of un as n tends to infinity is not equal to 0, we conclude that is enough to conclude, okay, this part is enough to conclude that sigma un is divergent. Conclude that sigma un is divergent. Suppose if somebody tries to attempt this problem without this condition, then that student has to take n common in the numerator, n common in the denominator, then this gets cancelled, then 1 by n power 0, taking vn as equal to 1 by n power 0 and continuing all these things by limit comparison takes a lot of time. So I hope you have understood this very well. So this is very tricky way to declare that the given series is divergent. If limit un comes equal to 0, nothing can be said. But if limit un is not equal to 0, be careful about this point, not equal to 0, then you can say that it is divergent. If limit un is equal to 0, nothing can be said. It can be convergent, it can be divergent if limit un is equal to 0. But if limit un is not equal to 0, then there is only one thing that is divergent. Be careful about this point. So whenever we are able to calculate the limit of the un and we are able to prove that it is not equal to 0, directly you can declare that it is divergent. I hope you have understood. So let's have some touch with another problem using this concept. Simply one thing I would like to suggest you that when numerator and denominator are polynomials of the same degree, directly apply this particular condition. Test the convergence of the series. Test the convergence of the series sigma n cube minus n square plus 1 divided by 4n cube plus n plus 5. Suppose n is equal to 1 to infinity. Now in the solution what we do is, here I am not writing detail, so un is nothing but equal to n cube minus n square plus 1 divided by 4n cube plus n plus 5. I just simply calculate the limit as n tends to infinity for this un, then dividing the numerator and the denominator with the same power. Whenever there are polynomials of the same degree, you apply this test better. This is a necessary condition test, or you don't give the name and just remember the necessary condition. So if I divide with n cube, I get 1 minus 1 by n plus 1 by n cube divided by 4 plus 1 by n square plus 5 by n cube, and on separation it will be 1 minus 0 plus 0 divided by 4 plus 0 plus 0, that is equal to 1 by 4. This value is not important whether it is 1 by 4 or minus 1 by 4, negative, positive, whatever it is not equal to 0. If it is not equal to 0, therefore given series is divergent. Given series is divergent. I hope you have understood.